Let's be honest, you've definitely heard of it, Schrödinger's cat. It's one of the most famous and, frankly, most misunderstood ideas in all of science. So today, we're going to pry open that box and finally unpack this quantum paradox.
I mean, just think about that question for a second. Can a cat be both alive and dead at the same time? It sounds completely impossible, right? Something straight out of science fiction. But this one single bizarre idea is at the very heart of a thought experiment that turned the world of physics completely upside down.
So, how in the world could a cat exist in this state of being both alive and dead? Well, to get it, we actually have to imagine what's going on inside that box. Let's walk through the setup of this legendary experiment. Okay, so picture this. You've got a steel box, totally sealed off from the world. Inside, there's a cat. But there's also this little contraption. It's a single radioactive atom that has a perfect 50-50 chance of decaying in the next hour. If it decays, a Geiger counter detects it, which triggers a tiny hammer to smash a vial of poison. If it doesn't decay, nothing happens. So the cat's life or death is now completely tied, or to use the physics term, entangled, with a totally random invisible quantum event. And this is where reality starts to feel like it's breaking. Because in the quantum world, things are weird. Until we actually measure it or look at it, that atom isn't one or the other. It exists in what's called a superposition, a kind of ghostly blend of every possibility. It is, at the same time, both decayed and not decayed. So if the atom is in a superposition of states, and the cat's fate is directly linked to that atom, well then the same strange logic has to apply to the cat. Until we open that box to check, the cat is also in a superposition. It is simultaneously alive and dead. I know, it sounds absolutely ridiculous. And you know what? That was exactly the point. And here is the single biggest misconception about this whole thing. Erwin Schrödinger never, ever believed a cat could be in two states at once. He invented this entire scenario for one reason, to criticize an idea he thought was absurd. I mean, listen to the man himself. In his paper from 1935, he literally calls the idea ridiculous. He was using this wild, extreme example to point out what he saw as a giant flaw in how his fellow physicists were interpreting the new science of quantum mechanics. So let's be super clear. This was never about zombie cats. It was a brilliantly constructed argument. It was designed to show just how bizarre and nonsensical things get when you try to apply the fuzzy rules of the tiny quantum world to our big, everyday reality. So who was he arguing against? His main target was an idea called the Copenhagen interpretation. This was the dominant theory at the time, and it basically said that reality, at its core, is just a cloud of probabilities until someone observes it. The act of looking forces it to pick a side. Schrödinger's cat was his way of saying, wait, seriously? You're telling me a cat is also just a fuzzy cloud of possibility until we peek inside the box? That can't be right. Now, to really get why Schrödinger's argument was so powerful, we need to zoom in on the one concept that makes this whole paradox possible in the first place: superposition. At its heart, superposition is a fundamental rule of the quantum realm. It just means that a tiny particle, like that atom in the box, isn't in state A or state B. It's in a probabilistic combination of both A and B at the very same time, until something interacts with it and sort of forces its hand. And this right here shows you the huge difference between our world and the quantum world. In our everyday classical world, things are definite, right? A cat is either alive or dead. A light switch is either on or off. But down in the quantum world, an atom can be decayed and undecayed. A quantum bit can be a 0 and a 1. It's playing by a completely different rulebook. And this all leads to what physicists call the measurement problem, which is the real mystery at the heart of this. What counts as an observation? How exactly does a quantum system go from that fuzzy cloud of possibilities to snapping into one single concrete reality? That is the profound puzzle that Schrödinger's cat put on full display. So how do we solve this thing? Well, for decades, some of the smartest people on the planet have been trying to figure it out. And they've come up with some pretty mind-bending interpretations, each offering a totally different way of thinking about what happens to that cat. And trust me, some of these ideas are wild. You have the original Copenhagen view, which says your act of looking somehow forces reality to make a choice.
But then you've got the many worlds interpretation, which suggests the universe literally splits in two, creating one timeline where the cat lives and another where it dies, and both are equally real. Each theory tackles the puzzle from a completely different angle.
Okay, so what's the modern take? Well, today, the most accepted scientific explanation for why we don't see zombie cats wandering around is a process called decoherence. The idea is that a quantum superposition is just incredibly fragile. The slightest little bump from its environment, a single air molecule, a bit of heat, anything, is enough to shatter that delicate state and force it to collapse. So in the real world, the cat's fate would be decided almost instantly, way before any person could ever get the lid off the box. So you might be thinking, okay, if decoherence solves the paradox, why are we still talking about this cat? Well, because the very same principle that Schrödinger found so ridiculous, superposition, has turned out to be the absolute bedrock of a massive technological revolution. A normal computer bit is like that light switch we talked about. It's either a 0 or a 1. That's it. But a quantum bit, what we call a qubit, is like Schrödinger's atom. Because of superposition, it can be a 0 and a 1 at the exact same time. And that ability to hold multiple values at once is what gives quantum computers their almost unbelievable power. And this is not just a theory anymore. Superposition is the engine behind quantum computers that are already starting to solve problems that were once thought impossible. It's the magic behind quantum cryptography, which promises to create security codes that are literally unbreakable. And it's allowing us to build sensors so precise they could change everything from medicine to navigation. And that right there is the beautiful, perfect irony of this whole story. The thought experiment that Schrödinger created just to show how absurd quantum mechanics was has now become the blueprint for building the future. His paradox became a roadmap. Which brings us all the way back to that deep philosophical question at the start. Even if decoherence explains why the cat is one thing or another, the measurement problem is still there. What is the fundamental nature of our reality? Is it a solid, fixed thing? Or is it a shimmering ocean of possibilities that only snaps into focus when something or someone is looking? That is the mind-bending, incredible legacy of Schrödinger's cat.